Our objective for this video is to solve problems that involve circles using radian information and trigonometry. So we're going to start by using problems that work with radians. So this first problem says a wheel with a radius of 24 inches has a piece of gum on it and revolves 50 radians. So if we have our circle and the radius of it is 24 inches, we can use the formula we have for radians that says that radians, if you have a radian value, is equal to the arc length over the radius. Now, if you have that, we can substitute in the numbers so we get 50 as our radian value. That's equal to the arc length, which we don't know, and put it over 24, which is our radius. If you multiply by 24 on both sides, you get that x equals 1200. So that's 1200, and the unit here is inches, so 1200 inches for this problem. So it traveled 1200 inches as it went round and round and round our circle, and the total distance it traveled. The next one is a car on a circular track with a diameter of 1.5 miles, covers an angle in standard position of 5 pi over 7 radians. How far did it travel? Well, this one we can use that formula that we just talked about because the angle is 5 pi over 7. And then that's going to be equal to the distance traveled, which we don't know, the arc length, over the diameter is 1.5. Now, we got to be careful here because the diameter is 1.5. So the radius will be 0.75. So that's why we'll have a radius of 0.75, half of it. And then if we multiply by 0.75 on both sides, and if you do 5 pi over 7 times 0.75, you get x approximately equal to 1.68. So we get an answer of 1.68 miles. Now the next one involves a clock. So I'm going to draw a clock here so we can use it as a reference for our problem. So a clock has a 12 at the top, then 1, 2, and 3. So when it says it starts at 8:15, the minute hand will be pointing toward the 3, and then we have 4, 5, and 6, 7, 8, and 9, 10, 11, and 12. And then when it goes to 9:05, the minute hand will end up at the 1, pointing to the 1. So it says what angle in radians is covered by the minute hand of a clock from 8:15 to 9:05. So it's going this way to get to that point. So what we need to do is recognize that a full circle in radians is 2 pi, and then recognize that, notice we've gone from 3 to 1, and that means we've gone 10 of the numbers. We've gone 10 of the numbers around the clock out of the 12 to get to the 1. We just didn't go do the 2 or back to the 3. So we've done 10/12ths of the circuit around the whole thing. And so if we multiply that, we get 20 pi over 12, which we can reduce. We can take out a 4 out of both of those, and we're going to get 5 pi over 3 for our angle. Okay, so that's what angle's covered from 8:15 until 9:05. Let's go to the next section, which is going to talk about what values of trigonometric functions are positive in which quadrant. Let's go ahead, though, and just review a little bit, just so that we think about like these x and y values. X and y, if you're in the first quadrant, x and y are positive. In the second quadrant, x is negative, whereas y is positive. In the third quadrant, x is negative and y is also negative. Over here to the left of the y-axis is the x is negative, and down below the x-axis the y is negative. And then here in the fourth quadrant, we've got that x is positive again, but the y remains negative. So if you notice, everything above the x-axis is when y is positive, everything below is when y is negative. And with the y-axis, the vertical axis, everything to the right of it, the x is positive, and everything to the left, the x is negative. Now on this diagram, we can draw in our x and y. If I drop down a perpendicular to the x-axis, this is the x value and this is the y value on that graph. That's what's represented on that triangle that's formed. Now we're going to draw in, we're going to call the hypotenuse the r for radius. And an important thing is that the r, the radius, is always positive. So when we're talking about positive and negative values, you've got to recognize that the r is always positive, okay? All right, now let's go ahead and talk about trig functions then. If you remember with this triangle that we have here, if we call this angle with the x-axis theta, we can talk about sine, cosine, and tangent. Well, if you look at this triangle, sine of theta is going to equal the opposite side, which is y, and it's going to be over the radius because that's the hypotenuse. So opposite over hypotenuse would be y over r. The cosine will be the adjacent, which is the x value, and it's going to be over the r, which is the radius, because that's the hypotenuse. And lastly, for theta, the tangent is the opposite, which is y, over the adjacent, which is x. So y over x for this. So if we're looking at ordered pairs, sine, cosine, and tangent, we can find those values using y, x, and r. We can also find the cosecant, the secant, and the cotangent by using the reciprocals. But we're going to focus on these for right now. Now let's talk about what their values are, positive or negative, in the different quadrants. If you look at these values, y, r, and x, if you look at the first quadrant, since x, y, and also r is always positive, so x, y are positive and then r is always positive, all trig functions are going to be positive in the first quadrant. Okay, so all positive here in the first quadrant. In the second quadrant, since x is negative, y is positive, notice anything with an x in it is going to be negative. So cosine and tangent are negative. Sine will be positive in the second quadrant. So sine theta in the second quadrant is positive. Now if we look at the third quadrant, again, we've got x and y both negative. So sine will be negative, cosine will be negative, but then tangent will be positive because you have a negative over a negative. So tangent will be positive in the third quadrant. So the ones I'm circling are the positive values, the ones that are positive, the other ones are negative. And then lastly, in quadrant 4, since x is positive, cosine is going to be positive, but y is negative, so sine and tangent will both be negative on this, so that we've got in the fourth quadrant, we've got that cosine is going to be positive. So I'm going to put a plus after these, just so that we see that these are the positive values in those quadrants. And also the reciprocals will be positive, but the other trig functions will be negative. And a way to remember that this is true, which ones are positive in which quadrants, we can use a phrase called all students take calculus. Now, why this is helpful, all students take calculus, is if you look at the first letter, that gives us, if we start at quadrant 1, all of the trig functions are positive in the first quadrant. In the second quadrant, sine is positive and it's reciprocal. In the third quadrant, tangent is positive and it's reciprocal. And in the fourth quadrant, cosine is positive and it's reciprocal. So that will help us remember using that phrase as to which ones are positive in which quadrants. So especially remember this box here, that when we want to do these trig functions, we can use x, y, and r. That's an important one. And then when are they positive or negative in which quadrants? All right, let's do one last example here. It says the terminal side of theta in standard position contains the point -2, -5. Find the exact values of the 6 trig functions of theta. So if we go -2 and then -5, we get an ordered pair down here. So this would be -2, -5. Now the angle we do, now just be careful, because at times people will draw the segments here, the rays of the angle, in the wrong place. For instance, what we want to do is we want to make sure we start by connecting this point back to the origin. That's the important one. Don't drop it to the axis yet, because sometimes you'll drop it to both. And then we want to drop it to the x-axis. So here, we want to get this perpendicular. So important to draw a perpendicular to the x-axis. After we do the terminal side over here back to the origin. So the angle we've done, the angle that we've formed here, is the angle that goes all the way around here. That's theta. But the angle we're going to use in doing this, the angle will just be the reference angle here. So it's this little reference angle inside the triangle that we'll use to get our different values. Now on the triangle, put your values. I've already got -2 up here on the x. I'm going to bring -5 over here on the side. I need to find out what my hypotenuse is. So I'm going to do the Pythagorean theorem. I'm going to take -2 squared plus -5 squared. I'm going to make that equal to r squared. So I get 4 plus 25 equals r squared. So r squared is going to equal 29. R will equal positive square root of 29. Remember, r can never be negative, so we don't do a plus or minus. We just do the positive. So I'm going to put the square root of 29 on this side here for my hypotenuse. And now I can do my 6 trig functions. So I can do sine of theta is equal to, and I'm going to do the opposite side, -5, over the square root of 29, my hypotenuse. Now we typically will rationalize that denominator, so square root of 29 over square root of 29 will give me -5 square roots of 29 over the if you square the square root of 29, you get just 29. Now if I want to do cosine of theta, that's going to be the adjacent side, which is -2 over the square root of 29. Do the same rationalizing the denominator, square root of 29 over square root of 29. That will give me -2 square roots of 29 over 29. And then lastly, if we do tangent of theta, that's going to equal the opposite side, which is -5, and the adjacent side, which is -2. Negative over negative is a positive 5/2. Now we can do the other 3 as well. We can get those by doing reciprocals. So cosecant is just the reciprocal of my sine. So I'm going to do the reciprocal before I do all the rationalizing the denominators. So negative square root of 29 over 5. I can bring the negative up on top or keep it down with the 5. That's fine. Either one's fine. Secant of theta. Again, I'll do it where at this point here, where right here, this part where before I do the rationalizing the denominator. So I have a negative square root of 29 over 2 with that negative. And lastly, cotangent of theta is the reciprocal of the 5 over 2, so it would be 2/5. So we've done circle problems here by taking the problems and working with our definition of what a radian measure is. And we did several of these problems here with circles and things that might be going around on tracks or around a circle. And then we used the x and y axis with a circle at the origin, centered at the origin, and we found sine, cosine, and tangent according to the x, y, and r. And then we talked about how you know which of the trig functions are positive in which quadrant. Then we practiced that with a radius problem where we had an ordered pair, and we found the radius of it, and then we found the 6 trig functions on the problem.